in my world, 12:29 rounds up to 12:30. So we're going to go ahead and get started. So first things first, exams got graded yesterday. I know that a lot of you were feeling very disheartened when you hit submit and it gave you a grade and you were like, what? I studied, I prepared. And I tried to warn you that it was going to be it was going to be bad when you first looked at it, because there was about 18 points or so that count as zeros no matter what, because I have to grade them, right? The sentences and that kind of thing. And then there are other pieces that, Ivy Learn just doesn't like. And so, if I coded it with a comma and you didn't put a comma, it counted you wrong. So I went back through, cleaned up everything. Our grades were phenomenal. Usually exam one grades are pretty rough. If I have one person in the 90s, I'm ecstatic. Gosh, I mean, multiple people in both classes. I have two classes right now, scored in the 90s, high 90s, very few low scores. Just really, really, it just shows you that you guys are really putting in the time. And yeah, well, Jacob, the first exam, people don't know what to expect. So I usually expect a lot of mid-range grades. I expect a lot of 70s, in the 70s. That's usually and in my past, that's been a good test one score. So for all of these 80s and 90s to come rolling in, I'm just ecstatic. You guys are really putting in the work. You're preparing. It's comforting to me, because I feel like I've kind of been absent while I was out of town last week, and you guys have just really stepped up and done the work. So I commend you. I know that there's a lot in this class, and you guys feel like you're just getting pounded. But this is week 4, right? We got 4.5 weeks to go and you're done. And so, you can do anything for 4.5 weeks. So I just urge you to keep plugging away. Don't get discouraged if you miss an assignment here or there, right? We dropped the 2 lowest, so it's okay. And we'll go from there. Yeah, it's really going to come back. So I just ask you that, if you did not do as well as you thought or you would hope, go back and reflect on what you did, and to prepare. If you have questions on, hey, this is what I did for the first exam, reach out. I know that we have the discussion board, and I tried to read those, but those are very vague. And so if you want to talk in detail about, preparations for the next exam, let me know and we can do that. Okay, but I was very happy. I hope you guys were at least. Okay, go back and look at your grade now after it's been graded. If you have questions, let me know. Today I finished the Excel grading and web work grades, updated quizzes, that kind of thing. So anything that was due before today has now been graded and is in the system. So I know some of you have already turned in stuff that's night. I have not touched most of that. A few people have turned in projects. I have not touched those. So anything that's due later, tonight or later, I haven't touched, because again, I'm also just trying to keep my head above water. So, but good. I'm happy. I hope you guys are happy. Keep working hard. Keep pushing through, and we'll see what goes on. So we are officially at the halfway point. So we're doing modules 7 and 8 this week. That will get us through the halfway point in this course. So I just wanted to bring up the modules here in the course to look at, so we can kind of have this 2-minute discussion. So we're doing module 7 is 2 sections, 12 and 13. 12 kind of builds more on sections 10 and 11 from last week. And then 13, I consider 13 kind of your relaxing section. It's about bar graphs and histograms, which tend to be a little easier than all of the conversions from 10, 11, and 12. So you've got the videos for those sections, your 2 web work assignments, and then you'll notice that we have an Excel assignment and a quiz. Now for that Excel assignment, I will be posting 2 videos that go with that. One of them is a video of bar graphs in Excel, and one is a video of histograms in Excel. So again, when you get to that Excel assignment, if you're not sure how to create these things in Excel, watch my short videos that I will post in the announcements, and those will kind of help you get through. I will also be posting stuff about Project 2 videos in the announcements, because you'll notice in Module 7, the Project 2 is assigned. And this is where things really start up, piling up in this class, because Project 1, that was assigned in Module 4, yep, module 4 isn't due until July 11th, right? I give you plenty of time to get through these. I posted the Project One Help videos in the announcements. Hopefully you've started that, because now this week we're going to say, hey, now here's Project 2. Get to work on it. So your things are going to start piling up. And if you don't kind of keep up on it, all of a sudden it's going to be a day and you're going to have a ton of stuff to do. So start sorting through, get yourself a calendar of when you're going to do these things. And if you have questions, let me know. Okay, so I will be posting help videos after class in the announcements. Then let's fast forward to Module 8. Module 8, not bad at all. Look at this thing. We've got 2 sections, 14 and 15, and they go together. We're talking normal distribution and z-scores in 14 and 15. And with that, you have 2 web works and a quiz. That's it. So no extra Excel, no project, no nothing else. So Module 8 is kind of a less workload. And you'll see those due dates are July 2nd, which is next Monday. So we've got June 28th, which is coming up on Thursday. So 12 and 13, you got to do a quick turnaround on those. And that shouldn't be too bad. Shouldn't be too bad. Okay, does anybody have any questions before we kind of get started on anything else, I guess? Dakota, yes, question. Section 11, number 2. Dakota, could I have your permission to go into your web work directly? Yes, okay. I have to ask that because we are, videoing and people are here and I'm going into your assignment. But if you're okay with that, then you have given me your permission. So I'm going to do that. Class list. These are your classmates. This doesn't show anything, but this is how I get into yours. Look at all these people who are active right now. All right, so Dakota, we are in section 11, and you said, are you sure number 2? Because you have 100% on that. How about number 3? Okay, that's all right. Okay. Oh, this is a really, really fun question. I'll do kind of a quick overview, but I will also post a video about this one for anybody else who maybe hasn't started this one yet. This is the paint problem. Because I do have a help video for this. I don't know why it doesn't come up. But here's kind of the basic. Where are my markers? There we go. Okay. So one thing to think about in this room is that any room that you're in, so think of like your living room. Generally, those are like rectangular in shape, right? So you're going to have 2 walls that are the same size, right? Because they face each other. And then you have 2 other walls that are the same shape. And then you have 1 ceiling, right? Because we are painting the ceiling as well, right? Painting the walls and the ceiling, but not the doors or the windows. So think about this. The rectangle, okay, so right here, it has a flat ceiling that is a rectangle that's 11 by 11. So the ceiling is 11 by 11. Rochelle, we'll get to that one let me get to this question, then I'll do that one next. So the walls are 7 feet high. So both of the walls are 11 by 7 because the top of the wall that goes with the ceiling is the 11 feet, and then the height is 7 feet. That doesn't seem very tall for a wall. Okay, so you have the dimensions of all of the walls, right? So this is total space. So you're finding the area of each of these, and remember there's 2 of each of these. So this is the total space, but you're not painting all of that space. So then you've got to go through and say, okay, I have a door that's 6 by 3. So you're going to subtract the door. So find the area of the door. Then you're going to subtract the 2 windows. Now the key with the windows is that this says 42 inches, and everything else that we're talking about is in feet. So you're going to have to take those 42 inches and convert those inches into feet. So by doing this step first, you will then have your dimensions of your windows in feet. Okay, I don't know if this is making any sense. But once you do, because of course I'm not going to do the problem for you. I'm kind of talking you through it. So this will give you the total paintable space. Total paintable. Then it says you're buying something. You can paint 100 square feet with a quart. So let's just make up an answer. Let's just say this is $8.50. If we can paint 100 square feet with a quart, well, we got to divide this by 100. That answer is 8.5. So I would need 9 quarts of paint at $4.50 a quart, and then I would multiply that by 9, and that's how you get your answer. Okay, so that's a quick overview without much math, kind of just talking through it. I will post the homework help video for that one. That will do a math walkthrough, and so if you need more guidance of you need to see it, that will help. And then for anybody else who maybe hasn't gotten there yet, I will post that help video. So lots of videos being posted in the announcements after class. Yeah. And that one's a little tricky. The inches usually is what throw people off. Yep. Okay, the next question comes from Michelle. What is the dosage error calculation project, and what are you supposed to do with it? Well, that is a super good question. Let me get my pointer out off my pen. Let's go back into this. That comes in module 6, I believe. Yep, it's module 6. It's due tonight. It's not real difficult. You shouldn't, don't fret if you haven't started this yet. So the dosage, and it's not necessarily a project, it's just a report. I will use, you're going to write a paragraph, so I don't want to make it sound too big. But in section 11, there's a problem in section 11 workbook. So if you watch the videos from section 11, hold on a minute. Let me find the exact page because that is most helpful. I've got my packet open. If you have your packet, you might want to earmark this. On page 94, I think it's page 94. I have an older version, but I'm pretty sure it's the same page. On page 94 at the very top, it should be the dosage calculation page. Can anybody confirm that page 94 is the dosage calculation page? Yes, thank you. Okay, so number 7 is the problem that I'm looking at. So if you are unsure on the process of this, you might want to go back and watch the video that goes with this page. So number 7 is the exact type of problem. And I think somebody mentioned of exactly what we're going to do. You're checking each patient. So you're going to start with patient A, and they're telling you that this patient is 215 pounds. And so this Levaquin drug, you get 6.5 milligrams per kilogram per day in 2 doses. So with that information, you take the weight of the patient using that dosage, and you figure out how many milligrams should this person be getting in each dose. And then you compare what you figure with the dose that they actually got in the hospital. So if you do the math and you get that the dose is 316.8, well, yeah, that's pretty close to 317. That's fine. But if you did the math and you got like 85 and they're giving the patient 317, well, they're going to kill that patient, right? So you're double checking that they've dosed correctly, because in a few of these patients, they haven't. And so you're trying to figure out which patients were overdosed, which ones were pretty much fine. And then you're going to do, you're going to do a little bit of a report of, and when I say report, I'm talking like a paragraph. It doesn't have to be long. You're just answering the questions of what happened, what were the errors, and if you can tell me the mathematical error, because some people can, some people can't. I usually give you about a ½ point bonus point if you can tell me the mathematical error in this problem. That first bullet right there says Excel might be useful. You don't have to use Excel. Excel doesn't have to be anywhere a part of this. You can do all of this by hand. You just need to have you don't have to use Excel. Some people like it because they can program Excel and it will do the math for them, but that's certainly not, it's not required. So if you want to use Excel, go for it. It does help if you know how to use it, but you don't have to do that. Yeah, if you wrote a conversion in Excel to automatically calculate, absolutely, absolutely. That's showing that, one, you understand the calculation, and you understand how to use technology. So those are both totally fine. Yeah. Some people hate Excel. They only use it when they absolutely have to. If that's you, that's fine. The goal of this is for you to kind of try to figure out where the error came in. And so yeah, Doug, a lot of people do way more than they need to. Who was it? When I graded the Excel assignments earlier today, and somebody went way above and beyond what they needed to do. I did give them a ½ bonus point because they went so far above and beyond. So, that's good. That is good. So, But that's the basics. So Rochelle, did I answer your question on what you needed with that? But I do recommend referring back to page 94, number 7, because that math problem of number 7 is basically the math that you're going to do for these. Yeah, highlighting the errors is totally fine. Yep. As long as I can kind of see what's happening just by looking, that's the key. Yep. All right, what else? Good questions today. Good job. That's kind of what I prefer this session to be about. I want to make sure that you guys get everything taken care of that you need to so that you can get off running when we're done with this. Because you have videos, right? Me doing problems is great, but you can watch all the videos later and you get all of those as well. So, any other questions, either on what stuff that's due tonight or stuff coming up? More practice for the metric stuff. Yes, in terms of, you have the packet itself, and then there are pages in the packet in the back. So one thing that I want to show you, let me stop acting like you. When you go into the web work, you see video lessons 080 as one of your homework assignments. These are, so we're in section 2, unit 2. Here are more videos on each section. So metric, customer, US to metric. And there are pages that go with these videos in the back of your packet. So I don't have that with me, I don't think. No. Sorry, I don't know what pages they are off the top of my head. But the back of your packet has extra pages for all of the conversions. And here, video lessons 080. Problem 2 just means unit 2. So those videos will walk you through anything to make sure that you have them correct, if you're doing that. And then if you still need more than that, I mean, let me know and I can see what else I can get you. Because yeah, the more you do, the easier it gets. And that's with anything, with math. Some of you mentioned that in your reflections about the exams. You did well in the stuff that you practiced, and the stuff that you thought was easy that you didn't look over, that's the stuff you struggled with. So really it is just the more you do, the easier you get. Okay, so we've got a few more questions. Yeah, that yellow sheet, page 245, 246, that has been sent to the Proctor site. So when you go in to take exams 2 and 3, they should provide you with that document. You can't bring your own because you could write on it, but they should give you a formula sheet, that exact one. So when you go into the exam for exams 2 and 3, if they don't give you a formula sheet, make sure you ask, because you need one for exams 2 and 3, and it has been sent to them. So they have it on file. You just, most of the time they give it to you no problem. I've had one instance where they forgot to give it to the student, and that student missed a lot of problems because he didn't have the information he needed. So make sure you advocate for yourself there. Okay. A lot of the problems we did in the web work, whoa. Oh yeah, memorizing all that crap would be ridiculous. Rochelle, what problems are you talking about that you didn't have the conversions? All of the stuff that we should be using should be coming from page 245 and 246, that yellow sheet. So there shouldn't be any conversions in web work that don't come from that sheet. So I don't, if you can tell me which one of those problems that would be.
Hey, what? Nothing. Talking to myself. Oh, you're talking to them? I was actually doing a lot of the problems with a tutor, the online tutoring, and they actually went to like Google to get a lot of the equation problem.
But you have a formula sheet. So
right, I have.
Yeah, if you go back, well, you have to find it. So that's the first key. If you go back in your packet to page 245, it's a yellow sheet. And I think I mentioned that in one of the videos. But if you go back to page 245, it's a yellow sheet. It's got all of the conversions on it, and that should be all you need to do all of the homework. Now, your tutor won't have that, but you should have that. That way, you have it on your end, and that's what you'll have. That's what you'll have on the exam. So, yeah, and yeah, the pages in your book are identical, right? So they were just copy and pasted from that page onto the formula sheet. That way, you have all of the identical stuff. It's just good if you start using that page 245 and get comfortable with it. That's what we're going to use for all of the sections that we need stuff from now on, and that's what you'll have on the exam. So it's good to kind of become comfortable with that. Yeah. But it's good. All right, what else? I feel like we're making progress today with questions. I love it. Sometimes when I just talk, I don't feel like we're doing much. But when you guys have questions, I feel like we're getting somewhere. I don't know why. It's kind of weird. Okay. All right. Now, my next question, there's 8 of you here in the live session today. Thank you again for coming. How many of you have started sections 12, 13, 14, 15, any of them? And if you have, what sections have you started? Put them in the chat box. If you haven't started any, you don't have to put anything. Okay, so none, which is fine. You almost looked at it. Well, I'll give you a high five for almost looking at it. All right. Okay. Well, if you guys had all started section 12, then I was going to maybe skip it, but it doesn't say. Okay, great. Then we'll just start with section 12 and we'll kind of go from there. We'll see how much we can get through here before 2:30. So section 12, again, is in... It's more conversions. So you guys did all the conversions on your own, right? Because last week I was out on Tuesday, so we didn't have the session. But did you watch the video that I posted? So I did post a live session for 10 and 11, so you had more videos. But you always have the videos in the modules that go with the packet, so that's always good too. So I am not prepared. I do not have my papers out yet. Section 12 is more conversions, but they are specific conversions. So if I could find them, that would be awesome. There it is. Great. Okay. So carbon dioxide emissions. You are going to need your formula sheet for this. Well, it's helpful. So the formula sheet, again, is page 245. It's yellow, which I like that it's bright and you can find it easily. You will notice about 1, 2, 3, 4, 5. It's the 5th big rectangle down, and it says carbon dioxide emissions on it. So we have 2 different conversions that we are going to use when we use carbon dioxide emissions. So if we are talking about gasoline, right? So every time you drive a car, you are creating carbon dioxide and emitting it into the atmosphere. And you are producing 19.8 pounds of carbon dioxide for every 1 gallon of gas you use. So this is, right, the identity ratio, that's the word I wanted to use, for gasoline. And that is on your formula sheet where it says CO2 from gas is 19.8 pounds per gallon. That's what that means. Now, we also could talk about electricity. When you have lights on, you run your clothes dryer, your dishwasher, your anything that is plugged into the wall and you're using electricity, produce 1.37 pounds of CO2 per 1 kilowatt hour. So that's the conversion that you use for electricity. So those are the 2 big conversions that we're going to need for this section. Okay, and we're going to just jump right into some problems. Man, I missed 1 week and I just feel all out of sorts. All right, I'm not going to do a ton of these problems, but we'll kind of do maybe 2 from gasoline. So I use 17 gallons of gas to get to work each week. how much CO2 do I produce? Now, some of these I like to work backwards. So when I think about gasoline and CO2, I know that I have to use 19.8 pounds per 1 gallon of gas, right? Gasoline, CO2, you have to use that conversion. Have to. So if you think about it from section 10 and 11, hopefully you've done some of the homework from those sections, so the factor label method makes sense. I want, CO2 is pounds, so I want my final answer to have the label of pounds. So if I want to get rid of gallons, where would I put gallons in the green ratio? Numerator, denominator, top or bottom? Where does gallons go if I want to get rid of it? Top, look at that, all over the place, right? So that tells me I need 17 gallons here. I can make anything a fraction by putting it over 1. So I just end up with my gallons crossing out. I multiply these two numbers together, and I end up with 336.6 pounds of CO2, right? That's kind of the straightforward problem for gasoline. Not too bad. Gasoline really isn't too bad. I mean, you can get a little bit tricky, but not a whole lot. Okay, you guys want to try this one? This one's a little bit more involved, but not too bad. I'll give you a minute so you guys can kind of try it. We'll see where we're at. Okay, we're talking about, again, gasoline. We're driving CO2, so we know we have to use the 19.8 pounds for 1 gallon. See how you guys did. And again, you can start from the other direction. I just tend to work backwards when it comes to gasoline because I think it's easier. I know I have to get rid of gallons. And when I look at this problem, this piece here is just 400 miles. There's nothing else that goes with it. That's just 400 over 1. But this is miles per gallon. So this is 37 miles over 1 gallon. And hopefully you recall from sections 10 and 11 that that means that can also be written as 1 gallon over 37 miles. Right? Did you guys get that one? So my green ratio would be 1 gallon is 37 miles. And I know that that's that ratio because that makes gallons disappear, and that's my goal, right? My goal is for gallons to go away. Now at this point, now I have miles that need to go away. So miles go on the top, so that's where the 400 comes into play. And using that yellow ratio allows my miles to go away. So if you think about it, you drove 400 miles at 37 miles per gallon. So by dividing 400 divided by 37, that tells me how many gallons of gas I need. That's a 3. Then I take that and I multiply by 19.8, and that tells me how many pounds of CO2 I'm using. So how many pounds of CO2 do I have in this particular problem? Two 1405. Yep. And that is pounds. Questions about gasoline? They're not too bad. You do a couple more of those on your own, and I think you'll have it. The gasoline ones tend to be pretty straightforward. You can't really get a whole lot of variation there. Unfortunately, with electricity, those tend to cause a few more hiccups. So let's go ahead and smash a couple of those. All right, so we're talking about a microwave. I use my microwave 6 hours a month. That's a lot of microwaving, right? If you think about microwaving or 2 or 3 minutes at a time. How much CO2 do I produce in a month from just my microwave? Now, if you reference page 102, page 102 has, oh my gosh, it's stuck, a whole list of appliances and their wattages. Okay, and I want to point this out because Project 2 is about CO2 in your life. And I like this project. I think it's pretty interesting, but it allows you to see what appliances do you use the most, how much do you drive, do the calculations, check out your carbon footprint, and then look at your like annual cost for electricity, annual cost for gas, and that kind of thing. So it's pretty interesting. I don't think you'll hate it. We'll talk more about the project at the end. I'll get into a little bit more detail on that if we have time. But you'll use page 102 to get the watts for the appliances that you're going to use in your example. So if we look at a microwave is in the kitchen. So I look in the kitchen section, about halfway down, I see a microwave. So where's my pen? I'm struggling today. So a microwave shows that it's 1500 watts. Okay. Now, if you recall, electricity and CO2 uses 1.37 pounds of CO2 per kilowatt hour. So we need to somehow get kilowatt hours in the numerator in order to cancel that out, right? That's our goal. Okay, well, let's see how much you learned in section 10. If my microwave is 1500 watts and I want kilowatts, how do I change 1500 watts to kilowatts? We are going to move the decimal. Which way and how many? So watts would be similar to liters, meters, and grams, right? Watts is in the middle. So if I want to go to kilowatts, which way do I go? We're going to the left, exactly. Because kilowatts is over here, watts would be in the middle. So we're going to go 1, 2, 3 spots to the left. So if I take my handy dandy red pen and go 1, 2, 3, that means I have 1.5 kilowatts. And that's what we want, because if I can get kilowatts, then kilowatts and kilowatts will cancel out. Now I'm just left with hours. So how many hours am I doing this for? This whole microwaving business. 6, yep. So 6 hours of microwaving. So now my hours cancel out with my hours, and now I'm ready to do math. So I've got 1.5 times 6 times 1.37, and that tells me how many pounds of CO2 I have. $12.33, absolutely. So the key with electricity is that you will always start with watts. Well, I'm pretty sure always you'll start with watts. So you got to change watts to kilowatts first, multiply by your hours, and then you're ready to roll. All right, let's try another one. You guys try this one. My electric clothes dryer is used 3 hours each week. How much CO2 do I produce in a year? And for those of you who don't have your packet, an electric clothes dryer is estimated at using 3,400 watts. Okay, you guys try this one. Shell, you are way low. Way low. Because remember, we're doing this for a year. I don't know if you got the year part. That might be why your answer is off. So this one's a little bit trickier. You got to add that piece in. That's one. There we go. There we go. So this is one where I would do a hashtag details matter. Okay, so we start with, if we have 3,400 watts, how many kilowatts is that? 3.4. Okay, so 3.4 kilowatts. Okay, our next step is hours. How many hours do we do this clothes drying business for? 3 hours a week. 3 hours in 1 week. But the question says, how much is in a year? So how many weeks are in a year? 52. So we got to take that 3 hours and we got to multiply by 52. You can either do it inside the problem or you can do 3 times 52 outside the problem and get 156 hours. Either way, it doesn't matter. You got to multiply whether you do it inside or outside. Once you do that, then you can say, okay, now I have kilowatt hours. So now I can do my 1.37 pounds is 1 kilowatt hour. Because kilowatts cancel out with kilowatts, hours cancel out with hours. So 3.4 times 3 times 52 times 1.37, and we're left with 726 and 648 thousandths of a pound of CO2. Right. So, yep. All right. How you feeling about that? Yeah, Dakota, so you took 3.4 times 3 times 1.37 and then multiplied by 52, right? Yeah, it's the same thing. Yeah, mathematically, by definition, multiplication is commutative, meaning you can do it in whatever order you want. It doesn't matter. So multiplying by 52, that's why whether you do it at the very beginning, do it in the middle, do it at the end, it doesn't matter. Yep, absolutely. Yep. It'll always work that way when you're talking about multiplication. Yeah. Good, good. Okay, making sure. All right, no other questions at this time. That's good. Oh, let me get rid of this. Okay, I just want to talk about standby mode real quick. If you look at your workbook, page 103 has standby mode wattages. So standby mode is when you have things plugged in, but they're not on. So like right now at my house, I have 2 TVs plugged in. I've got, I don't know, 5 lamps plugged in, my refrigerator, my microwave, my stove, my computer, got all kinds of crap is plugged in. I'm not there, right? So everything is turned off, but it's still drawing power, right? I still have to pay an electric bill, even when I'm never home, because those things are still sucking energy. So we call that standby mode. And you probably heard of that with like computers, right? If you don't touch a computer for so long, it shuts down, right? It goes into standby mode. Same concept. Okay, so obviously things that aren't on use less electricity than when they are on. So when you're looking at page 103, the number of appliances is drastically cut down from page 102. And part of your project will also be dealing with standby mode appliances. So you are going to need some of these things on that page as well. So your DVD player is on standby mode approximately 20 hours a day. How much CO2 is produced in a month when you're not using it? Okay, so I want you guys again to try this one. Your DVD player in standby mode is 1.55 watts, right? That's standby mode. So go ahead and try this one. Okay, we've got two answers with the same numbers, but different decimal points, which makes me say one of them is probably right. Okay, so we're starting with 1.55 watts. What is that in kilowatts? Because remember, what is your first step? Watts to kilowatts. And how do we do that? We go left 3 places. 1, 2, 3. So we're starting with 0.00155 kilowatts. Okay, so there's our first step. How many hours? So it's 20 hours a day for 30 days. So 20 times 30. And again, you can multiply by 30 anywhere you want. And then we have the 1.37 pounds per kilowatt hour. All right, so that's the correct mathematics. When you multiply, you should get 1.2741 pounds. And that there is the correct answer. So for those of you that got 1,241 or 1,274.1, my guess is you did not move your decimal here, because that's generally, yeah, that's the biggest mistake people make when it comes to electricity, is they forget to go watts to kilowatts. So you really need to be careful with that. Make yourself a note. Really pay attention to your denominator. That's kilowatts. So you've got to have kilowatts in this place. Watts and kilowatts are not the same. Not the same. Okay, any other questions about carbon dioxide emissions for right now? Or else we're going to call it. Yeah, you know what? The details matter, and usually it just takes one thing, whether that's an exam or a project or something, and it really does get into that. Speaking of projects, as you guys start turning in exam one, I'm starting to get my feet underneath me. I will start grading exam ones probably here in the next couple of days, because I want to get that feedback back to you before you turn in project two. I think it's important for you to see how I grade those projects. That way if you turn in both projects before I grade the first one, if you make the same mistake twice, that's not fair to you. So it's always good to kind of learn from your mistakes and where you're going and what we're doing, and so that's important too. So I just wanted to throw that out there. Okay. All right, so that's all we're going to do in this section. Section 13 is bar graphs and histograms, and I'm not going to spend a ton of time on this section because, again, I think it's fairly straightforward, and I think if you watch the videos that are present, you should be okay. But I want to kind of point out the big difference between bar graphs and histograms. Well, let me ask you this. Do any of you know the difference between bar graphs and histograms? Maybe I should start there. Anyone? Anyone? All right. Used a bar graph in your dosage project. All right, great. Okay, so here's a histogram is a type of bar graph, but it's a specialty one. So here's the big thing. Bar graphs deal with categorical data, meaning maybe we are graphing cars on a car lot. And so there's blue cars, there's red cars, there's yellow cars, there's green cars. So every bar would be a different color, right? Categorical. Or maybe we're talking about the number of runs scored in a baseball game. 1 run, 2 runs, 3 runs, 4 runs. Even though those are numbers, they're categorical because they're showing how, like a certain number type of a thing, okay? Where a histogram shows continuous data, or I guess this is sometimes called discrete. Discrete data is categorical, using some correct mathematical terms here. So histograms talk about numerical data in terms of continuous. And let me show or describe what continuous data means. So if we're talking about water in my water bottle, okay, I could have 1 ounces or 2 ounces of water, but I can also have 1.5 ounces or 1.2 ounces or 1.234 ounces. So when you're thinking about data and you're thinking about numbers, the way to tell the difference between a bar graph and a histogram is, okay, look, if I have numbers 1 and 2, can there be anything between them? If the answer is yes, then you have continuous data. If the answer is no, like runs in a baseball game, you can't score 1.5 runs. That's not how it works. It's either 1 or 2, so it's categorical. The blood in my veins, I could have 1 pint, I could have 2 pints, but I could also have 1.5 pints. So because I can have those decimals in between, it would be continuous data, right? Let's talk about age, right? Years. On your birthday, you turn 36. Great. On your next birthday, you turn 37, but every day in between that you are a decimal, right? First, you're 36 and 103 and 1/365th, right? You're yet a decimal. So because you have all of those decimals in between, your age is continuous data, right? Does that make sense? How you can kind of classify the difference between those two? Okay. Another way to kind of look at it in terms of visual is with bar graphs, the bars do not touch, right? So it looks like this: bar, 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 bar. There's bar. Ooh, that's too close, right? There's space between the bars. With a histogram, the bars do touch because remember we talked about that the numbers in between, the 1.5s. So if you're graphing a histogram, you've got this bar and then you have this bar. They share sides, right? So you can visually see the difference. If you see a graph that has the bars touching, you're talking about continuous data. That's why they touch. Okay, that's the big takeaway from section 13. I do want to point out that page 111, because a lot of people say this section is so easy, I don't need to do anything with it. And that's fine. You don't want to watch all the videos, don't, right? It's your world. I'm just living in it. But I please do recommend, if you don't watch any other videos in this section, watch the video that go with page 111. It talks about frequency tables and distributions, graphing a histogram, and how to tell mean and median from a graph. Okay, and so I really encourage you to watch that video. There is a web work question that I get questions on all the time, and if you watch the video that goes with page 111, it will pretty much show you how to do that web work question. So I really, really, really encourage you to do that. Okay. Okay, any other questions on that? That's all I'm doing from section 13 right now, because it's already 20 after 1 and we haven't gotten to the other stuff. So, okay, any other questions on sections 12 or 13? All right. Let's go to our next PowerPoint. So, we are now in module 8. What just happened? Oh my gosh, my screen just broke. What the heck is happening? Hold on a second, I'm having faulty. I have two, there we go. I have 2 monitors and all of a sudden things are just weird. Okay, so section 14 and 15 go together hand in hand. They're 2 of my favorites because, I don't know, they just are. We're getting into the empirical rule, and I have a video that's just called the empirical rule. It's like 3 minutes long, and it shows you the basics of, I knew I was missing a page. It shows you the basics of that, and so before I get to that, let's talk about the normal distribution. I'm getting ahead of myself. Okay, have any of you heard of the normal distribution? Or played? Okay, so the normal distribution basically says, that's a nice straight line. This is a graphical representation of the normal distribution. All right, so we have any data that is approximately normally distributed will fall in this kind of pattern, where if you cut right down the middle, you will notice that pretend that's a straight line. The left and the right side are approximately symmetrical, right? They're pretty much the same. And so the value that cuts this right down the middle is the mean. So in a normally distributed problem, the mean, the median, the mode are all directly in the middle. That's not really what we need to get into. But the area under the curve, so all of this area underneath here is 100% of your data, which that's going to come in handy when we talk about the empirical rule in about 2 minutes. So all of the area under the curve adds up to 100% of the data that we're dealing with. I've already mentioned that this is symmetrical, so the left and the right side are going to be the same. And the area under the curve, all of this under here, it references probability. So we can use certain area pieces underneath the curve to say, you know, the probability of this happening is 40%. So we can tell that just by looking at the curve. And we are going to need your formula sheet here in a little bit when it comes to section 15, just FYI. Okay. All right, so let me erase this. Now you can tell by looking, if I have two drawings, okay, so you can tell by looking that these are, I'm going to tell you, these are both normally distributed, but they're obviously very different, right? One is tall and skinny, one is short and wide. So those are very, very different. Now, the mean falls directly in the middle of each one of these. So we could say, if I said, which one of these would you say is more spread out? Would you say A or B is more spread out? B, exactly. So when we think of something being spread out, we would say that this one has a large standard deviation. Is this the first time we talk about standard deviation? Or has that come up before? All of my semesters run together. I think this is the first time as well. Okay, so let me get back into that. So if we have a wide, letter B is really wide. We have a large standard deviation. And letter A, it's short and skinny, right? The mean is in the middle. All of the data is really clustered around. So this one would have a small standard deviation. Now, what do I mean when I talk about standard deviation? Well, just to put it in normal people words, because we are normal people. Well, I will assume you are normal. I am certainly not. But anyway, standard deviation talks about the spread of your data. How far is your data from the mean? That is basically what standard deviation is all about. So when you're looking at it graphically, that's why if something is really spread out, we have data all the way out here. So if the data is really far away from the mean being the blue vertical line, then we're going to have a large standard deviation because my data is really spread out. In letter A, where it's tall and skinny, and most of my data falls really close to that vertical line, because it's all really close, it's going to have a small standard deviation. A lot of times with exams, I did not do it for our exam, so this kind of fall flat on my face here, but I'll calculate the mean and the standard deviation for our exam scores. And so if I have a lot of 70s and 80s, and then I have like one person with 100 and maybe 3 people with 40%, right? It's really spread out. So that would make my standard deviation a little bit bigger. Whereas this year, this semester, most of the grades were in the 70s, 80s, and 90s. We had very few that I would call outliers. All right, we had the occasional maybe 55 or a 50, but usually I have multiple people in the 30s and 40s. I'm talking like 5 or 6. And that didn't happen this semester. So this semester we would have a small standard deviation because most of our data is clustered together. Right? So when you're looking at data, if you have a large standard deviation, and when I say small and large, that's all relative to what you're dealing with, right? So it's hard to give it a numerical value to that because it really depends on your data. But you can tell by looking at graphs whether or not the standard deviation is going to be big or small. Okay, we are going to use standard deviation in talking about the empirical rule and z-scores, which is how we are going to spend our next bit of time here together. Okay. Okay, the empirical rule. Now, I don't know about you guys, but I really struggle applying something when I don't understand where the numbers come from. And on page 122, they kind of tell you this is the empirical rule. It's just kind of thrown up on the page, and then you're expected to use it. And I don't really, that's not how I work. So I just want to spend a few minutes, if you'll allow me, and I want to show you where all of those numbers come from on that page, because I think it's easiest to explain. And I also think it's best if you use a concrete example. All right, so bear with me. But hopefully it'll make a lot more sense after this. So I'm going to make up an example, and I'm going to tell you the mean is 70, and the standard deviation is 5. So that little curly Q type thing is sigma, right? The Greek letter sigma, and it's that denotes standard deviation. So we've got mu is our mean of 70 and our standard deviation of 5. So based off what I said earlier, if I draw a line right down the middle, what value is right down the middle? 70, exactly, because our mean is right down the middle. So let's go ahead and write that in there. Boom. Okay, so standard deviation talks about how far our data is from the mean. And, excuse me, the empirical rule is also sometimes known as the 68, 95, 99.7 rule. And what this means is, let me change color for effect, 68% of our data is one standard deviation from the mean. So if I go one standard deviation in each direction, think of the horizontal line as a number line. So if I'm going to the right, I'm going to add one standard deviation. Well, what's 70 plus 5? 75, right? And on the other way, I subtract a standard deviation. So 70 minus 5 is 65. So we would say 68% of our data falls between 65 and 70. Let's pretend these are test scores. The average was a 70. That means 68% of students scored between a 65 and a 75. That's what the empirical rule says. Now, if the empirical rule says 68% falls between these two pink dots, right, from here to here is 68. 68%. If we know this is symmetrical, so my yellow line splits everything in half, how much would fall on either side of the yellow line? If the whole thing, pink to pink, is 68, how much would be on just one half? Not 35. The value from pink to pink is 68%. There you go, 34. So we would take 68 and we would divide it by 2. And that's how they get 34% on each side. So 34% of students would fall between a 65 and a 70. Okay, and these are all the numbers that are on page 122. I'm just showing you how they come up with them. Okay, all right, so now let's continue on with our empirical rule. Okay, so now I don't want to use green, I want to use gray. So 95% of our students will fall within 2 standard deviations to the mean. So I go one more standard deviation out. That means I would take 70, and I'm adding 2 standard deviations. So each standard deviation is 5. So 70 plus 10 would give me 80. In this direction, I take my 70 and I'm subtracting 2 standard deviations. So 70 minus 10 would give me 60. Now this is where the math can get a little bit interesting. So from gray to gray, from 60 to 80 is 95% of my students. Now I'm going to do some math up here in the corner. I have 95 from gray to gray. Remember that from pink to pink was 68%. So how much is left over in my gray area? If I used 68% going from pink to pink, but gray to gray is 95, how much is left? What's 95 minus 68? $27. So there is 27 in these 2 gray areas. Okay. And again, it's symmetrical. So how do I find out how much is in each of those chunks? Divide by 2. Yep. Since there's 2 equal spots, we would take 27 divided by 2. And this gives me 13.5. So each one of these sections holds 13.5% of data. So if the question was, what percent of students scored between a 75 and an 80? 13.5. And now we could even say, what's the probability a student would score between a 70 and an 80? Because then you could just add those two together and get 47.5, right? You just look at the two barriers and you add everything in the middle. Okay, but we're not done. So we're on the last one. 99.7 is 3 standard deviations away. So I'm going 1 more standard deviation in each direction. So now I'm at 85 on the right, and I'm at 55 on the bottom, or on the left. So from orange to orange is 99.7% of my data. Okay, so let's go up and we'll do some more math. So I have 99.7% is orange. Recall that we've already used 95% of our data going green or gray to gray. So how much is left in my orange areas? Not 2.7. 99.7 minus 95 is 4.7, right? But that's split into 2 equal pieces, so I have to divide by 2. So I get 2.35%. These are all percents, by the way. 2.35. Now, hopefully somebody says, but we have a problem. The problem being this whole thing is 100%. So the whole thing is 100%. I've already used 99.7% in orange, which means I have 3.3% left for what we call the tails. Again, we're symmetrical, so we divide by 2. So this is 0.15%, and this one over here is 0.15%. And that's where the numbers come from. So they give you this table of all of these percentages on page 122, and you're expected to be able to use them, right? So if we would say, what's the probability of a student scoring greater than an 85? Well, here's 85. Greater than that would be to the right. The probability would be 0.15%. Okay. All right. Any questions just on what I just did in general? If you do, there is a video just called the Empirical Rule where I pretty much just do that. But I think it's important to understand where the numbers come from. Otherwise, it's kind of hard to use them. Okay, so let's go ahead and talk about this. So this is a 5-part problem. And it's going to be important that you draw the first piece. That way we don't have to come back to that every time. So the average mile per gallon in luxury cars is 29 with a standard deviation of 3. So the first thing that we're going to do is we're going to draw a normal distribution curve, labeling through 3 standard deviations from the mean. And then we're going to do a bunch of probability. So let's go ahead and draw that curve. Where are you always going to start when you're drawing a normal distribution curve? In the middle, exactly. What value goes in the middle in this problem? 29. Good. I guess that could have been on here. The mean is 29, and the standard deviation is 3. All right. And we'll just do this all in green. How do you get your values to the right? You add 3, exactly. So we got 32, 35, 38, and to the left we subtract 3. So 26, 23, and 20. And just in case you need to remember, put your percents in. 34, 13.5, 2.35, and 0.15. Now, before you freak out, because this, as you will notice, is not on your formula sheet. So the empirical rule percentages are not given to you for the exam. That simply means you are not expected to use them on the exam. You can, there's a spot where you can use them, but you do not have to. We have another method of how to do the problems. We're going to get to that in section 15. Okay. Okay. I'm going to give you a second because I'm not going to redraw this. We're going to do the rest of the problems with what you guys have. You're going to give me the answers without me doing all the work, which is awesome sauce. Okay. So I just want to give you a second, make sure everybody has it written down with the numbers they need. Okay. Wait, is everybody good? Anybody need more time? Y'all golden? All right, let's do the next problem. So what is probability the car gets less than 23 miles per gallon? Okay, so locate 23. It's down here somewhere, right? Which way is less, to the left or the right? To the left. So for this first example, we're trying to find the area to the left. So you'll add up all the percentages to the left of that vertical spot. And what do you get? 2.5%. So the probability a car gets less than 23 is 2.5%. Now, what about getting more than 23? Which direction are we looking at if we want more than 23? To the right. Okay, how do we figure that out? You actually have two options. Can you tell me one way? Oh, good. All right, so Chris said, well, we could take 100% and just subtract 2.5. Yep, that's the easy way to do it. Because you know the entire thing is 100%. So if you do the entire thing, right, the left and right have to add up to 100. Or, Isadora had it right, you could just add all of these pieces to the right. Either way, you're going to get the same answer. But the whole idea of complements, that's what the 2.5, the 97.5, two numbers that add up to the whole are called complements. We will get more into that next week. Yeah. Okay, good. What about the probability of somebody getting between 20 and 32? So here's 20, here's 32. We want between that. What do you get? $83.85. Yep. Because you got the 34 here, 34, 13.5, and 2.35. So if you add all four of those percentages together, that gives you the 83.85%. Is everybody seeing where these numbers are coming from? Is anybody having issues? Okay, and what about how likely is it that a car will get more than 38 miles per gallon? So here's 38. Which way is more? To the right. Okay, so if we're going to the right, when it says how likely, you still need to quantify that. So what is the probability? .15%. Yeah, Yep, so it's not very likely because 0.15% is pretty small. All right. How do you feel about section 14 with the empirical rule? That's basically what it's about. Okay. Now, can anybody point out a problem with the empirical rule? I mean, the mathematics behind it is fine, right? It's not too bad. You use your numbers, you're golden. But can you think of anything that I don't know, any comments about it? Okay, in the real world, that's true. Both sides might not always be equal, but there it is. How about anything in between the whole numbers? Yes, that's what I wanted to point out. Okay, so this is the example we just got done playing with. These were the numbers. And the empirical rule is super fly fabulous when you are talking about these 7 numbers. Okay, I'm guessing that you guys have a car or somebody you know has a car. Do they get exactly this many miles per gallon? Because I'm telling you right now, my car tells me how many miles per gallon that I'm getting, every time I get gas, it resets and blah, blah, blah. It's almost never exactly on one of these numbers, ever. Like right now, I think I'm like at 36.4 miles per gallon. Well, 36.4 is like right here. That tells me nothing, right? So you're exactly right that the empirical rule is great for 7 numbers. It's really good for an estimation, right? Those percentages are estimates. So if you're just looking for a quick estimate, the empirical rule is fabulous. But if you're looking for anything better than a generic estimate, it's just not good enough, right? If you want to know about 30 miles per gallon, this isn't getting it done. So that's where section 15 comes into play. And section 15 not only will do these numbers, but it will do everything in between. All right, so that's kind of our lead in. Okay, z-scores. So a z-score, it's very important that we just understand what a z-score is. A z-score is a way to standardize data. So let me give you a real life example of z-scores because this has affected my life. So I did my dissertation a couple years ago, and I was using placement test scores at Ivy Tech. So if you came to Ivy Tech in the last, I don't know, 4 years, you took the AccuPlacer. But if you came to Ivy Tech before that, you took the Compass test. And they have 2 very different grading systems. They had different means, they had different standard deviations because they were 2 very different tests. So when I did my my dissertation, I had 60,000 sets of data. Yes, 60,000. And I had to go through, and first I had to categorize them, put all of them together that took the AccuPlacer, all of them together that took the Compass test, and then I had to find the mean and standard deviation of each one. Well, I needed all of this data to go into one group because I needed to do one test and I needed to treat them all the same. So instead of having an AccuPlacer score and a Compass score, I turned everything into a z-score. So a z-score is a way to standardize data. They were both placement tests. So I used the mean and the standard deviation for each test to change it into a z-score to standardize the data so I could treat that as one set. And that is why z-scores are fabulous, because it doesn't matter what we're looking at, whether it could be test scores, it could be shoe sizes, it could be ounces of waters in water bottles, the amount of lotion used every day on feet. I mean, literally anything. And you could convert it to a z-score and then it's standardized, and we can talk about it in all kinds of different ways. So z-scores are fabulous. So they're a way to standardize data. And what it tells you is it tells you that the number of standard deviations you are from the mean. Okay, that's the definition of a z-score. So with that being said, the mean of the data will have a z-score equal to 0. So when we think about our picture here, right, our mean's in the middle, so this z-score would be 0. What can you tell me about any number to the right of that? Any number over here is going to be what? Positive, exactly. These are all going to be positive z-scores over here. And they're positive because they're above the mean. And that should make sense if you think about a number line. So anything to the right is positive. It's above the mean. Anything to the left is going to be negative because it's below the mean. Okay, it's a negative z-score. So if I would say you have a z-score of 1.2, that means you are 1.2 standard deviations above the mean. It's above because the score is positive. If I would change it to a negative z-score, then you'd be 1.2 standard deviations below the mean. Okay? Okay, that's kind of just in general. Now let's kind of get to it. Super exciting. I really like this section. Okay, we really need, it'd be very, very helpful for you to have your yellow sheet out right now so we can look at that real quick. So in order to use our probability table on page 246, we need to be able to find z-scores. And so the first formula you see is also right under the table on the left. Z equals x minus mu over sigma. So to find the z-score, we will take your value that's in question, we will subtract the mean, and we will divide by the standard deviation. So that's why when I talked about my example earlier, as long as I had the mean and the standard deviation of the data, I could turn everything into z-scores. And then once it was all z-scores, then they were all the same and I could put them in the same group. So what we're doing here, and we're going to, of course, we're going to do examples, a bunch of examples for all of these. But let me talk about what the table on page 246 represents. Remember with the empirical rule, the area under the curve represented probability. And so we found, hey, this was 34%. The empirical rule just gave that to us. But with the z-scores, it's not as friendly. So when you're thinking about all of this, okay, so we're going to find the z-score first. I'm just going to make it up and say this z-score is 0.8. Okay? Now, if you look at the table, find 0.8 under the z-score portion. It's in the third column. What probability is associated with 0.8? Good. 0.7881. The table always gives you area to the left. Always. So if 0.8 gives me an area to the left of 0.7881, how would I find the area to the right? Because what if I wanted to know greater than a z-score of 0.8? Exactly, exactly. Remember, the whole thing is 100%. And 100% as a decimal is just 1. So if I would take the whole thing of 1 and subtract the area to the left, that would leave me the area on the right of 0.2119. And that's this side. So using the idea of complements, right, the table always gives you area to the left. Always. Area to the left. So I am a big fan of drawing pictures and shading the side that I want because it's so easy to say, oh, z-score 0.8, you look at your table, you write down the answer. But if you wanted the area to the right, the table is not going to give you that. The table is going to give you area to the left. You've got to do the math to get to the right. Okay, I'm done talking. Let's do some problems. Average calories burned at the gym is 460 with a standard deviation of 35. First things first, let's find the z-score of somebody who burnt 510 calories. So remember, formula for a z-score, x minus mu over sigma. So the first step really is identifying what we have. What does 460 represent? Average calories is 460, right? It's the center, yeah. This is the mean. The standard deviation is 35. 510 is the value in question. We care about the person who burnt 510 calories. So we can take those three pieces and put them into our formula. The value of 510 is what we care about. We subtract the mean of 460, and we divide by 35. Now, you want to make sure that you're subtracting your numerator first before you divide. That'll be crucial in your mathematics. And let's go ahead and round to the nearest tenth. $1.4. If you do your math and your number is nowhere on this sheet, then you probably made a mistake, right? So 1.4 is on the sheet, so that's good. All right, so that's my z-score. That means this person who burnt 510 calories is 1.4 standard deviations above the mean. I know it's above because it's positive, and that makes sense. 510 is bigger than 460, so logically that makes sense. Okay, let's keep that z-score in mind as we move to the next question. What is the probability of someone burning less than 510 calories? Well, this is where I like to do a table here. I know that 510 calories associates with a z-score of 1.4. That's what we just found. You know what? Let me get rid of these drawings. Okay, so 510 associates with a z-score of 1.4. So when I draw a picture, 1.4 is bigger than the mean, so it's going to be to the right of the middle. This is 1.4. Burning less. Which way is less? Left or right? Left. So we're trying to find all of this area over here. So I look at my table, and what does it tell me? 0.9192. So the probability of somebody burning less than 510 calories is 91.92%. I do want to point out that your table gives you 4 decimal points. There are some web work questions that tell you to round to 3 decimal places. So if you don't round correctly, it will count you wrong. Just throwing that out there. And what's the probability of somebody burning more than 510 calories? Well, more is to the right. So how do I figure that out? Yep, we just subtract from 1. So 1 minus 0.9192 gives me the 0.0808. If you're going to round, like let's say we wanted to round this one. So 1, 2, if we want to go to 3 decimal places, you look at the 4th number. In this case, 8 rounds up. So this would be 0.081. For the value on the left, if we look at the 3rd place, right, so 2 rounds down, so this would just be 0.919. You just look at the 4th place and then round up or down accordingly. Oh, that should work. I think on the test it allows all 4 places because that's what we give you, so that makes sense. Yep. It's one of those things that you just got to read the directions. People get so frustrated, and I'm like, well, you know what you're doing, you just can't read, right? It's a blessing and a curse, really. So, okay, let's go ahead and have you guys try one. Ooh, let me get rid of the drawings here. All right, so the average calories burned are still 460. Our standard deviation is still 35. What is the probability of somebody burning less than 400? So we're finding probability, right? So you're still going to do this whole thing, whatever, but there's no way to know this. So the first thing you have to do is find a z-score. Find a z-score, figure out where it goes on the chart, and then find the probability of somebody burning less than 400. Okay, see what you can do. Give yourself a minute or so. All right. So again, mean, standard deviation, value. So z-score, value minus the mean over the standard deviation. So you end up with negative 60 over 35, which rounds to negative 1.7. And you always want to round to the closest to the table. So negative 1.7 is going to fall somewhere over here. In which direction are we looking, left or right? Left is correct. So we look at our table. We find negative 1.7, and we should get 0.0446. Whoa, that's a horrible looking 4 right there. Here we go. Questions on that one? Are you understanding where these numbers are coming from? Nope. Yes. Good. Okay. Anybody else? Yeah. All right. Let's do one more, and then we'll talk about the project and we'll be done. So the average calories, we're still dealing with 460 and 35. Now we want to talk between 440 and 500. So 440 is going to be over here, 500 is going to be over here, and we need to somehow find this area in between. I'm going to give you a minute or two to see if you can figure out how to do that using z-scores. If you have no idea, just hang out for a second and we'll get there. But I want to see what you can do on your own first. And if you get stuck, go ahead and tell me that too. All right. Okay, so if we think about it, what do you know how to do with the information that we're given? You know how to find z-scores, right? So we have two different values. So let's find two different z-scores. So we can use 440 as my value. I know my mean is 460. I know my standard deviation is 35. And I can use 500 as my value. I have 460 as my mean, 35 as my standard deviation. So the first thing we can do is we can find two z-scores. All right. Now, when I do this one, I get negative 20 over 35, which rounds to approximately negative 0.55. Okay. And I'm using two decimal places there because if you look at the z-score table on your yellow sheet, when you are less than 1, or between negative 1 and positive 1, they go to two decimal places for their z-scores. Now, on this one, I'm at 40 over 35, which comes out to be approximately 1.1. Okay, all right. So z-scores, that's what we know. We can do that, we have that, great. From that point, if you look at your yellow sheet and you say, okay, I know that the area to the left of negative 0.55 is 0.2912. Well, okay, so yeah, your negative 0.57 and your 1.14, those z-scores are mathematically are fine, but then you go to your yellow sheet and you say, what's the closest thing that I have to negative 0.57? And the closest that I have is 0.55. And then you look at 1.14, what's the closest that I have? 1.1. So you just, whatever you find mathematically, you go to your yellow sheet and you find what's the closest that I have. Yeah, you're going to have to round. Yeah. And if you took your negative 0.57 and you rounded up to negative 0.6, that's fine. There's nothing wrong with that. You'd get an answer that's slightly different, but that doesn't make it wrong, right? It's just different. Okay, let me change colors for effect, because to the left of 1.1 is 0.8643. So if you think about it, that pink line, all of the pink line is 0.8643. The orange line is 0.2912. So how do I just get this portion up here? Can anybody think of a mathematical way to only deal with that, ooh, excuse me, that one spot? Yeah, exactly, we subtract. Because if we subtract these two, take these two numbers, the overlapping piece will cancel out, which is this part, and we're only left with the with that part that doesn't overlap. So when I subtract 0.8643 minus 0.2912, I simply get 0.5731. And so the probability would be approximately 57%. The probability somebody burns between those calories, about 57% of the time. Right? You can change your decimal into a percent. So that's about the hardest problem that you would see in terms of z-scores, because it's got a little bit more involved, but it's not too bad. All right. Any other questions? That's kind of the basis of sections, well, I guess 12 through 15 today. That wasn't too bad. That wasn't too bad at all. Okay, if you'll bear with me, I would like to talk about the second project just for a minute. That way, I mean, I'm going to post I don't have a walkthrough video. I just have the help you get started video. What am I looking at? Here we go. Modules. So project 2 is down. Here it is. So due July 20th, so just 9 days after the first project due, you've got your second project due. So, and I am going to post the Excel help video with this, but here's the deal. So in Excel, you're going to create a spreadsheet, and you're going to use 6 appliances you use on a regular basis. I would recommend using things that use big wattages, like a clothes dryer or something else that uses a lot of watts, that you use a lot, because the more watts you use, the easier the project is. So you need 6 appliances that you use on a regular basis and 5 energy vampires, and they can be the same. So if you use your clothes dryer 8 hours a week, then the other 160 hours a week, it's still plugged in, but you're not using it. So it becomes an energy vampire. So you can use the same ones. But it shows you what else you need to enter in, and you are going to use formulas in Excel. And if you're like, I don't know how to do that, watch the help video that I post. It'll help you do that. Okay. So you're going to do electricity usages, and then you're also going to talk about gasoline consumption. So how much do you drive? And this is an estimate, right? You don't feel like you have to track your mileage for a week. Just estimate, how many miles do you drive? And again, you're going to use Excel formulas to figure all of this out. And if you don't drive on a regular basis, so you think it's going to be boring, you know, pick your wife, your girlfriend, your boyfriend, your mom, your dad, your cousin, your brother, whatever, right? This is just for informational pieces. It's not huge. We just want to kind of see how things go. And then you're going to calculate total pounds of CO2 for electricity and gas together. You're going to do annual cost, 12 cents per kilowatt hour. And for gasoline, how much is gas right now? When I passed Meyer on the way in today, it was $2.99. Thank goodness I got it yesterday at $2.65. Okay, then you're going to do the total cost. So you'll do the cost for each one and then add them together. That's all on one spreadsheet. Then you're going to take that spreadsheet, you're going to copy it, and you're going to paste it into a second spreadsheet where your job is to reduce your CO2 output. So you're going to figure out, should I hang dry my clothes? Should I carpool to work? Should I unplug unplug my microwave when I'm not using it, right? Just different kind of random things. And then you're going to write me a small reflection paper where you're answering these questions. Okay, and again, I mean, a couple paragraphs, nothing huge, just answer the questions. Okay, but that's the basic walkthrough. Again, I will be posting a video that kind of walks you through the Excel portion of how to do these formulas in it and things. But that's the basis of Project 2. Very much goes along with Section 12 in your packet. So, yeah. Okay, any questions on that? I just want to kind of do a quick overview so you kind of had a little bit of an idea of what was going on. But that's all I got. So if you don't have any other questions, I will post all the videos. I will, of course, make this video reachable. That will go into the announcements as well when it becomes available. But do you have any other questions? All right, I'll stick around for a few minutes, but if you don't have any other questions, go off, enjoy your day. Thanks for participating. I appreciate it as always. And of course, email me with questions. If you have them, bring them. I will try to stay caught up on grading as much as possible. And again, Project 1, get that going because you want to get these projects turned in and you don't want them hanging over your head. That's good. But okay, so take off. Have a good one. And Rochelle, I will stick around for your web work question. Thanks, guys.